Welcome to this explainer. I'm absolutely thrilled to dive into this with you today, because we're looking at something that honestly feels a bit like science fiction, but it's rapidly becoming our everyday reality. We're exploring some groundbreaking insights recently published in Nature by Dan Fox and David Castelvecchi. Their piece, How Do Quantum Computers Work, really signals that quantum computing is, well, officially entering an entirely new era. So get comfortable. We're going to jump straight into this fascinating and, yeah, highly complex quantum horizon. 10. I really want you to burn this number right into your mind. It's the ticking clock. According to the latest breakthroughs we're seeing in the source material, there's this growing, almost palpable hope in the scientific community that usable quantum devices could be here in just 10 years, literally a single decade until we potentially build machines capable of solving truly intractable problems. I mean, just think about where technology was 10 years ago, right? Now imagine what the next 10 are going to bring. It is a wildly fast timeline for something this revolutionary. Okay, let's dive into this. Section 1. A new quantum era and the core mysteries. To really grasp the sheer magnitude of this era, we have to look at the foundational conflict driving all this research. And it sounds almost too simple, you know? What even is a quantum computer? Seriously, as Fox and Castelvecchi point out, scientists are sprinting toward this 10-year finish line to build a machine when they're actually still trying to define its fundamental physics. It's kind of wild when you stop and think about it. So the crucial point is really the gap between our current capabilities and this massive quantum promise. Conventional machines, the servers and laptops we use every single day, they have hard mathematical limits. Quantum devices, on the other hand, promise to totally conquer problems that we currently categorize as completely intractable. Figuring out how to bridge that specific gap, well, that is exactly where all the current scientific obsession lies. Moving right along to Section 2, the big unanswered questions and a century of debate. Look, you just can't engineer a machine that defies conventional logic without brushing up against the much broader ecosystem of quantum physics. I mean, current research is deeply entangled, pun totally intended, with concepts like building a secure quantum internet or achieving quantum supremacy, where a quantum device actually outperforms a classical one. And then there's deciphering quantum spookiness. Physicists are literally still arguing over theoretical debates that kicked off a full century ago. And guess what? Those exact same arguments are what's fueling today's hardware breakthroughs. Which brings us to Section 3, the accelerating pace of development. Let's look at a snapshot in time. Despite a whole century of ongoing arguments, the pace of development right now has quickened into this dizzying flurry of concrete breakthroughs. Just look at a single month from the research. On July 8th, researchers published on reinforcement learning control of quantum error correction. Boom. 1 week later, July 15th, papers drop on universal gates from fusing anyons. Fast forward just one more week to July 22nd, and the literature is suddenly flooded with insulator-free topological photonic multi-lane highways. Honestly, it's relentless. The field is moving incredibly fast. And this brilliantly illustrates Section 4, the quantum research landscape and pushing the boundaries. So yeah, there's a pretty staggering gap between basic public understanding and this cutting-edge science. Fusing anyons and photonic multi-lane highways, I mean, it sounds straight out of a sci-fi movie, right? Dealing with exotic quasi-particles and light-based data paths. But actually, scratch that, I want you to remember our ticking clock here. This sheer volume of highly complex, incredibly specific research isn't just academic noise. It's the heavy lifting. It's the exact engine actively driving us toward that 10-year goal. Every single one of these dense papers is like a giant puzzle piece snapping right into place. So if this mountain of complex research truly translates into usable devices in a decade, we're looking at the year 2036. Which means I have to ask, are you ready? Are we ready for a world with a quantum internet? A world where the intractable problems of today are just solved by machines we're still, right now, struggling to fully comprehend? The quantum horizon is approaching fast, and I, for one, absolutely cannot wait to see what it reveals. Thanks so much for joining me on this explainer.